Okay, we're going to do R2, the quadratic formula. You've seen this stuff before. Before we do the formula, we're just going to review square roots real quick, how to simplify them. You might want to write down the list of perfect squares. You should know how to produce this list on your own. It's just 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. Let's just go up to the first 12. So 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12. Alright, let's go ahead and just simplify these square roots. We want no decimals here. No decimals. That's the worst E I've ever drawn in my life. Sorry, no decimals. So look at the square root of 144. Actually, because it's on the list, it's just 12. That's easy. We have the square root of negative 25. Look, 25 is on the list, but because we're taking the square root of negative, the answer is not just 5, it's 5i. It's not negative 5, it's 5i, because recall that I is equal to the square root of negative 1. Alright, and then, so that's just a quick review of square roots and imaginary. And then we also have to reduce square roots sometimes that are not perfect squares, but a perfect square goes into it. Now you want to find the biggest perfect square that goes into the number you're looking at. Now I'm looking at 112, and I want to find the biggest perfect square that goes into 112. So that was me rolling over to get my calculator. So I just get my calculator out, and I say, okay, I want a number that evenly goes into 112 that's on this list, the biggest number possible. Well, 121 is too big. 100 probably doesn't go in there. 81 is more than half of that. I mean, we could try 64. I don't think it's going to work, but here we go. We got a decimal, so yeah, let's try 49. No, that doesn't work. Let's try 36. No. Let's try, I don't think 25 can't go in there, so let's try 16. Okay, good. 16 times 7 is 112. So we're going to go ahead and rewrite the square root of 112 as square root of 16 times square root of 7. The reason why we do that is the square root of 16 is a nice whole number, and we just keep the square root of 7 because we can't reduce that further. Okay, let's go ahead and do that here. Notice that we have a negative side of the square root, so that means eventually our answer is going to have an I in it. So let's just recall that I equals square root of negative 1. But otherwise, let's go ahead and look for a perfect square that goes into negative 128. Again, 121 I can't divide evenly in there. 100, no way. You want to try 81? I mean, I don't think it works, but here, let's just check it out. Yeah, it doesn't go in there. Let's try 64. Hey, 64 times 2 is negative 128. So, okay, we know that so let's just focus on the square root of 128 for a second. That's 64 times 2, keeping both of those numbers in square roots. The square root of 64 is 8. Then we had square root of 2, but because we have the negative there, let's just go ahead and put an I between the whole number and the radical. Okay? So that's just a quick review of square roots. You should know how to do that. Make sure you know how to do that. To remind you of the quadratic formula, there it is real quick if you want to write it down. Just remember it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, you can only do that when you have your quadratic in this form, meaning you have ax squared plus bx plus c. So basically, make sure it's equal to 0. Okay? So let's see what we're working with. I just did a couple of problems. Again, this is review. This is stuff you already know how to do. I'm just reminding you for your notes and everything. So if you look at this quadratic, you can tell it's quadratic because it's x squared. But we're not equal to 0. This is positive 3. I think we should probably move this over here. So I'm going to go ahead and subtract 3 from both sides so that we can get equal 0 on this side. Now the minus 3 has no like terms over here, so I'm just going to go ahead and write it in this form. Again, we're trying to get it into ax squared plus bx plus c equals 0 form. Okay, so it looks like a is going to equal 2, b is going to equal negative 1, and c is going to equal negative 3. Alright, I'm just going to go by the formula. So I know it starts off with negative b. So if b is negative 1, negative b will be positive 1. I'm just going to write the formula down just in case you want to see it on the screen as I work these out. Oh yeah, so negative b is positive 1 because there we go. Plus or minus square root of b squared, so negative 1 squared minus 4 times a times c, so 2 and negative 3. All over 2 times a, which is 2 times 2. Okay, so we're going to end up working on the inside of this radical. On the bottom, we can, real quick, do 2 times 2 is 4. Okay, so negative 1 squared is positive 1. Now I need, so that became positive 1. And then I need to do negative 4 times 2 times negative 3. So just get your calculator out. You have, so here's what I noticed. I have 2 negatives are going to make a positive. So I can just put a plus sign. Now I just have to do 4 times 2 times 3. And get 24. Well, I should probably just do 1 plus 24 real quick, and I get the square root of 25 all over 4. The square root of 25, this is why we reviewed square roots real quick, is the square root of 25 is 5. Okay, and then you just split up into 1 plus 5 over 4 and 1 minus 5 over 4. So it looks like x is equal, so we're just going to simplify these and we can determine x. So 1 plus 5 is 6 over 4. And 6 over 4 can reduce to 3 over 2 because it's a fraction it can reduce. So I have a comma here for my other answer. 1 minus 5 is negative 4 on top over 4. Negative 4 divided by 4 is negative 1. Okay? Shouldn't be mind-blowing. It's stuff we've done many times. Let's go ahead and do part B. Again, make sure it's equal to 0 first. This one looks like we're going to have to move this guy over here. Because it's negative 4x, we're going to have to add 4x to both sides. 4x is not going to be a like term with any of these. So we want to get it into this form. I want the x squared term first, so I want negative x squared first. I want the x term second, so I'm going to put plus 4x right here. Then the minus 5 will go right here. And these are going to cancel, so we get 0. Again, if it helps, a is negative 1, b is positive 4, c is negative 5. And just go plug into the formula. So in this one, negative b. So b is 4, negative b is negative 4. Plus or minus square root of b squared minus 4 a c. And just plug in numbers in. All over 2 times a. On the bottom, 2 times negative 1 is negative 2. All right, in the middle, on the inside of the square root, we have 4 squared is 16. I have negative 4 times negative 1 times negative 5 that's going to go right here. So negative 4 times negative 1 times negative 5 is negative 20. So I have minus 20 right here. 16 minus 20 on the inside of the square root is negative 4 all over negative 2. Now remember, with a negative inside the square root, remember that I equals square root of negative 1. So what happens here is I'm going to have an I from the negative, and the square root of 4 is 2. Now look at all three of these terms, the negative 4, the 2i, and the negative 2. They all have a 2 in common, meaning you can divide 2 out of all three of these. So negative 4 divided by 2 is negative 2. Keep the plus or minus. 2i divided by 2 is just I. And then negative 2 divided by 2 is negative 1. And what we can do is split up the fraction like this, so that negative 2 is over negative 1. Plus and minus is right here. And I is over negative 1. But what can we do with negative 2 divided by negative 1? That's positive 2. Keep the plus minus. And then I divided by negative 1 is negative I. But because of the plus minus, you can just put I right here. And this is the answer. All right. So just to remind you, that's the quadratic formula. Sorry, I just realized I was out of frame. So there you go. I apologize for that.